Good day everyone and welcome to another math vlog by your tutor man. This is the first video in the series exploring the classical problem of doubling the cube. Do you wonder how to bring the learners to the time of ancient Greek thinkers on the story and solution of the problem of doubling the cube? And are you curious about illustrating the concepts of geometric mean and double mean proportions using GeoGebra? And have you thought about how to illustrate the visual proof of the ratio governing the proportions of two similar cubes to be used for the dilation task using GeoGebra? So if yes, please join me in this series. As an overview, this series is an improvement on my video lesson on the Conics and the Delian problem. The link of that video lesson is in the description below. I would recommend everyone to view the story in this video. Now please pause the video to read the following learning objectives. At the end of this video lesson, everyone should be able to appreciate the spiritual and philosophical significance of collectively solving problems and puzzles as one humanity. And we can draw inspiration from classical success stories as a leap of faith in transforming society towards ideals of social cohesion. In this video lesson, we will emphasize the elegance of the geometric mean in describing the geometric relationship between side A and B using the geometric mean x. And solving for x, we will just cross multiply and we get the solution. Later, we will discuss more about the geometric mean. The concept, discoveries, and academic discourses around geometric mean evolves into the discussion of the double mean proportion. And we will also thoroughly discuss the concept in this video series. Let's translate the geometric mean notation in English. So we have a side of one triangle, we call it A, that has a geometric relationship with the side of another triangle, and we're calling it B. And then these two triangles each have a pair of congruent sides we call X. Through X, we're able to establish a geometric relationship between sides A and B from different triangles. This geometric mean likely became evident when dividing an acute triangle into two right triangles using an altitude. The altitude creates segments whose lengths are related to geometric mean properties. It only works when sides A and B are being added together and formed the longest side of the triangle. The ancient Greek thinkers, such as students of Plato, were actively exploring and having academic discourses around the proportions and ratios between triangles. In such interesting geometric pursuits, they thought of splitting the acute triangle into two right triangles using an altitude, and they discovered that such an altitude, we call it x, is a geometric mean for the equation A is to x equals x is to b. Here's a historical note. The concept of geometric mean was explored by early Greek mathematicians like Pythagoras and later formalized by Euclid in his book Elements. Doubling the cube problem, which involved similar proportional reasoning, was studied earlier, around the time of Archytas of Tarentum. Again, at that time, they also have this problem statement: how to construct the length of square root AB geometrically. So let's visualize everything. So please have a look at this acute triangle. So A plus B here is the longest side of this acute triangle. And then we're going to divide this acute triangle into two right triangles through the altitude x. By studying this kind of construction, the ancient Greek mathematician noticed that the proportion of the short leg A of the smaller triangle to its long leg x is equal to the proportion of the short leg x of the bigger triangle to its long leg b. So again, there is a proportion between a and x that is equal to the proportion x is to b. So you have a over x is equal to x over b. Again, by cross multiplication, x times x is x squared is equal to ab. Now have the geometric mean x is equal to square root of ab. We can always go back to the time of the ancient Greek mathematicians by reconstructing the numerical value of the geometric mean square root of AB. So please watch this video to guide you through it. Alright, so here's a glimpse of that video lesson. So we're going to construct x so that A is to x is equal to x is to B. So please continue to watch this video lesson until the end, and feel free to recreate such a construction to appreciate the ancient Greek way of visualizing geometric numbers such as the square root of AB. So let's construct the geometric representation of square root of AB in GeoGebra. And here are the steps. So first, we're going to go to GeoGebra Classic. That's geogebra.org/classic. And then we're going to create an acute triangle. And then we're going to draw the altitude. The altitude is BD. Now we're going to measure side A. So side A is side AD. And then side B is side DC. And the measurement of the altitude is 10. So side AD plus side BC is equal to 25. And that is longer than BC because BC is only 22 units. So again, this geometric mean property is only applicable for acute triangles where A plus B is the longest side. Now we're going to recreate these two right triangles here. And then we're going to transfer it into the original acute triangle to prove that these two small right triangles are indeed equal to the acute triangle. So we're ready to transfer this small right triangle here to the acute triangle. So we're just going to create a vector and then use the vector for the transfer. Please observe. Now the bigger right triangle back to the initial acute triangle. So we have visually proven that these two right triangles are indeed the two right triangles of this acute triangle after dividing this acute triangle into two right triangles using the altitude. here. All right, so let's calculate now the ratio A is to X. So our A is AD, our X is BD. So AD over BD, right? So we have 1/2. And then the shorter leg of the bigger right triangle over the longer side of the bigger triangle. So that would be X over B. So X is BD and B is DC. All right, so we also have 1/2. Using arithmetic, we have proven that A over X is equal to X over D, and that X is the geometric mean of A and B. That's the end of the first video. I would like to thank our dearest writer educators, Mr. Bondo, Mr. Villia, and Dr. Pawilin, for writing this beautiful book, History of Mathematics, that I am currently reviewing. This historical artifact serves as a beautiful inspiration to students like me. And thank you also to Rex Bookstore for printing such an inspiring book. And to all of you who have been watching my video lesson and reading my teaching documents, thank you so much. This is Tutor Maan, and I hope that you have learned something.